problem B, we have a wooden crate which weighs 10 kg this time, being pulled horizontally along the ground at an acceleration of 3 meters per second squared. The coefficient of friction between the crate and the ground is 0.2. It's a very similar situation to problem A. This time we're going to find the tension and we have the acceleration. So we're going to go ahead and draw the free body diagram first of all, as always. The weight is mass times gravity, mg. This is m, and you multiply it by g. Again, we have a reaction force because it's on the ground, and we have a force here pulling it along the ground, P. Call it T, tension. In the last question we called it P, if you recall. And here again we have mu r. Same thing again, modeled as a particle, constant acceleration. The rope is inextensible. That's another modeling assumption. So it doesn't stretch, so it doesn't store energy. If it stored energy, this would be equal to kx, but it's not. It's just a fixed number, one number that we're going to find. So sum of F is equal to ma. All the forces in the x direction. Now, since this is moving this way, because it's being pulled, so it must be going this way, that's winning over that force there, then we know that right is positive. Direction of motion is always positive. That means this one is positive and this one is negative. So P minus mu r is equal to ma, and that's the sum of forces. Now, we don't know the forward force, we're looking for it. The coefficient of friction is 0.2, so it's 1 over 5 again. And r again, there's only two forces, so that must equal that. R is 10g equals 10a. The acceleration in this case is 3 meters per second squared. So we're going to have P. Now, 10 divided by 5 is 2 equals 30. Add 2g to both sides. You get P is equal to 30 plus 19.62. Add these together, that's 49.62. So P is equal to 49.62 newtons.